Hello everyone and welcome to video number 4 in the FEMM 4.2 course. In the previous video, video number 3, we covered the required steps to build an electrostatic or electromagnetic project. We started from selecting the problem type, building the structure, selecting the material, and creating the mesh. But we didn't solve the problem yet. To solve the problem, we need a specific application. In this video, we are going to cover an electrostatic problem, Trough Test Problem, to cover steps 8 and 9, and we will see how to assess the results and get the outcomes from this problem. If you remember, we solved this problem before using hand calculation in video number 1. So we are going to compare the results. Let's go! For the trough shown in the figure, we need to model the system using FEMM 4.2 as an electrostatic planar problem. All dimensions are given in centimeters as we can see here. So the width is 25 centimeters, the height is 20 centimeters, and we are going to take the depth 1 as the problem is planar. So we need to determine the electric potential and electric field at the conductor points 1 to 12. So this structure is divided to segments. Each segment is 5 multiplied by 5 centimeters. So we need to plot the voltage and electric field for contours, middle contour and lower contour. The middle contour is points 5, 6, 7, 8, and the lower contour is points 9, 10, 11, and 12. So we are going to choose this point as the 0 point. So that one will be 0, 0. And the voltage here for this conductor is 100 volts. And for these conductors, the voltage is 0 volt. That one is a copper conductor. So now I'm going to build that one in front of you, but I'm going to make it in a speedy mode because we did that one in video number 3. My main focus is how to get the results, how to assess the results. So let's go to the FEMM now. So when you click on the FEMM icon, you are going to find this screen in front of you. So I'm going to choose File, New, or click here, New. I'm going to choose Electrostatic Problem. Okay, we're going to see the capacitor here. So we are going to build our problem now. So choose a problem, planar. I'm going to choose that 1 centimeters. Okay. So now I'm going to follow the steps 2 up to 7 to build this structure. So let's start. Now it's time to create the mesh, but we didn't save our file. So if we click create mesh without saving the file, we anticipate that we are going to have an error. So let us see what will happen. A data file must be loaded or the current data must be saved. So we are going to save our file now. File, save as, we are going to call it Trough. So let's create our mesh now. We created the mesh with 6,421 nodes. Let's click OK. It's time now to analyze the problem or solve the problem. So either go for analysis here and click on analyze, or click on this icon here. So I click on that one. So that one is going to solve the problem. As you can see, that one is very fast compared to other finite element softwares. But we didn't see the results. Either going for analysis here, click on view results, or click on this Google. So click on that one. You are going to another screen showing you the results. I move the image of the problem to the left where we can see the density plot for the voltage. So the hot color means the higher voltage and the cold color means the lower voltage. But what will be the case if I like to know the voltage, electric field, or field density at a specific point, for example, like this one? So I need to make sure under the view menu that points prop is ticked. So when I'm going to click on the point, I'm going to see all the properties. Let me snap to grid, choose this one. So the voltage of this point is 54.4 volt. The electric field will be 732.9 volt per meter. So and I like to know the pattern of the voltage, the pattern of the electric field. What I should do, I'm going to click on line. I'm going to choose from this point up to this point. That one is a middle contour. I'm going to click on graph, voltage. Okay. So I'm going to see the distribution of the voltage for the conductor from 0 point up to 25 centimeter, starting from 100 volt up to 0 volt. What about the electric field? I'm going to repeat the problem here. Click on the graph. Choose instead of voltage, the electric field. Okay, so we are going to find that one starts from 1000 volt per meter up to something like 100 volt per meter. What about the lower contour? So I'm going to disable this line. I'm going to select the line again. I'm going to choose from this point to this point. So that one is a lower contour. I'm going to repeat the procedure to plot the voltage or the electric field or the field density. But rather than clicking on the icon, I can go for the menu here, plot X and Y. I'm going to plot the voltage. As you can see here, we started from 100 volt up to 0 volt. I can configure the difference between the middle contour and lower contour. So I need to save the data. Let's see how we're going to do that one. So to do that one, we are going to plot X and Y. Rather than going to plot here in this screen because I don't like the graphic style here, so I'm going to write that one to a text file. Okay, so I'm going to ask me to save it. I'm going to call it maybe lower V. Save. And I'm going to repeat the procedure again for that one. And I'm going to plot the voltage, write data to text file. I'm going to call that one middle V. Save. So now we save the files to text files. So we need to take that one from a text file to either MATLAB or Excel. We can plot it whatever we like. So before we leave this screen, we're going to look for different buttons here. What this one? If we click on this one, this means that we can select a certain area. If we click here, we have this area inside that one. So we can integrate now. Either you click in the integrate menu or click on the integrator sign. So here we can calculate some features. Something like stored energy, block cross-section area, block volume, average flux density, average electric field, and so on. So for example, what is the cross-section area for that one? So we have something like 0.05 meters square. What is the stored energy? Let's see. What is the stored energy? So that one will be something like 4.910 to the power minus 9 joules. So what this one? That one is going to calculate the capacitance of this conductor. For the high voltage one, we have 100 volt. We have this charge. So C equals Q over V. So it's time now to return back to our slides to see the difference between the results from finite element analysis and our hand calculations. Let's go. If we return it back to video number 1, we solved this problem using finite difference method. For example, point like number 8, the voltage was 50.3 volt after 7 iterations. A point like number 1 is 1.7 volt. What about the results from our FEMM software? So for a point like number 8 is 54.38 volt and point like number 1 is 3.1 volt, which is more accurate compared to that one because we stopped here for 7 iterations and here we solved that one using finite element techniques. So we plotted the figure here to start the voltage at 0 point for the middle contour and lower contour until reach 25 centimeter. So that one started at 0 volt. As you can see, the middle contour, that one is the blue one, and the lower contour will be the red one. So how do you plot this graph? So if you grab the graph from the finite element software, it didn't look like this one. I mentioned that we saved the file as a text file. So we are going to see in the next slide how to plot a graph like this one. So how to plot the curve using MATLAB. As we can see here, this is a graph when we take it directly from FEMM. It didn't look nice. We need to adjust the ligand, we need to add grid, we need to add the labels and so on. So if we do it using MATLAB, we have something like that one. We can add the y-axis and x-axis labels. We can add ligand if we like. We can add the graphs, two graphs in the same figure and so on. How we are going to do it? Going to the workspace, write data equals load data.txt, and that one is the name of the file. You save it from that FEMM. And x equals data colon and 1, y equals data colon and 2. And you can plot x and y. Here you can hold the graph and add another line. Let's go into the MATLAB and do it together. So before you are going to load your data, make sure that you have the path, correct path, where the files are here, the text files you have are here. So we are going to write data equals load, open bracket. I'm going to write the file name middle v.txt, semicolon. So that one accepts the file now. I'm going to assign the x-axis to x1, call it data colon 1. And y-axis, which is the voltage, I call it y1 equals data colon 2. I'm going to upload the other file as well, data, that one's called lower. x2 equals data of all and 1, and y2 equals data of all and 2. So now we can plot x1 and y1. So that one shows to us x1 and y1. So we are going to hold our figure, plot x2 and y2. Let's check. So now we have two lines here. One represents the middle voltage or the middle contour, and that one will be the lower contour. Now I can click on this arrow, adjust all the axes, I can add all the labels, I can add grid, I can add any legend, whatever you like. Then you are going to save your file here as file, save as whatever you like, that one dot figure, and you can take it to whatever document you like, any Word document, PowerPoint document, and so on. So let us recap this video. We succeeded to finish all the steps, step number 1 up to step number 9 through this application and the previous video. What will I watch in video number 5, the next video? We are going to cover another electrostatic application, underground cable. See you in the next video.